Hello my dear student, I am going to discuss about Edexcel IGCSE Certificate in Physics, Movement and Position. Chapter 1, Movement and Position. All content applies for triple and double science. I am JAHANGIR'S. I am a physics teacher. My contact number is 01717979515. Edexcel Specification. Section 1, Forces and Motion. Chapter 1, Movement and Position. Movement and Position. Learning objectives for this chapter. After finishing the chapter, you can plot and explain distance time graphs. Know and use the relationship between average speed, distance moved and time taken. So, average speed equal to distance moved divided by time taken. Practical for the chapter, investigate the motion of everyday objects such as toy cars and tennis balls. Know and use the relationship between acceleration, change in velocity and time taken. We know acceleration equal to change in velocity divided by time taken. Acceleration is denoted by small letter a. A equal to final velocity minus initial velocity divided by time taken. So, A equal to V minus U divided by T. Here, V stands for final velocity and U for initial velocity and T for time taken. Plot and explain velocity time graph. Determine acceleration from gradient of the velocity time graph. Determine distance traveled from the area between the velocity time graph and the time axis. Use the relationship between final speed, initial speed, acceleration and distance moved. So, final speed square equal to initial speed square plus 2 acceleration into distance moved. So V square equal to U square plus 2AS. Here V stands for final velocity, U for initial velocity, A for acceleration and S for distance. Now, first topic of this chapter. First we have to learn about distance and displacement. What is distance? The total path covered by an object irrespectively to its direction is called distance. So, it is a scalar quantity because it has only magnitude, no direction. Unit meter. On the other hand, displacement, the total path covered by an object in a particular direction is called displacement. It is a vector quantity because it has both magnitude and direction. Unit, the unit of displacement is same as that of distance, that meter. So, major difference between distance and displacement is distance is scalar quantity because it has only magnitude, and displacement is a vector quantity because it has both magnitude and direction. Now, second thing, average speed. What is average speed? Average speed If a body does not move with uniform speed, then average speed is obtained dividing the total distance traversed by the total time. So formula, average speed equal to total distance divided by time. In physics, speed is usually measured in meter per second. You can also use distance equal to speed into time. And if you need to find out the time but distance and speed are given, then time equal to distance divided by speed. You can remember these things by using formula triangle of the distance, speed and time. So this is a formula triangle. You can find out easily all formula from this formula triangle. This technique is very useful for find out the formula between or among speed, distance and time. Now sometimes you need to convert speed from one form of unit to another form of unit, like 1 kilometer per hour. So kilometer per hour. So we know 1 kilometer means 1000 meters. So 1000 meter per hour. Now, but 1 hour equals to 60 minutes, and again 1 minute equals to 60 seconds. So 1 hour equal to 3600 seconds. Therefore, 1 kilometer per hour equal to 1000 meter divided by 3600 seconds. So 1 kilometer per hour equals to 0.28 meter per second. Remember this thing, 1 kilometer per hour equal to 0.28 meter per second. And 1 meter per second equal to 3.6 kilometer per hour. So remember these two things, very important. 1 kilometer per hour equal to 0.28 meter per second, and 1 meter per second equal to 3.6 kilometer per hour. Also, sometimes you have to convert kilometer per hour into mile per hour. So 100 kilometer per hour approximately 63 mile per hour. There is a mathematical problem. Question number 1. Calculate the average speed of the car that covers 500 meters in 200 seconds. Already we learned about average speed. So average speed equal to total distance divided by time. So here total distance 500 meter and total time 220 seconds. So 500 meter divided by 20 seconds equal to 25 meter per second. Now question number 2. Sound waves travel at about 340 meter per second through air. How far will a sound wave travel in 1 minute? Read the question first. Sound waves travel about 340 meter per second through air. That means this one is the speed of sound, 340 meter per second. How far will a sound wave travel in 1 minute? So we know distance equal to speed into time. Here speed equal to 340 meter per second, but time is given in minute. So we have to convert it into second, 340 meter per second into 60 seconds, because we know 1 minute equal to 60 seconds. So answer 20,400 meters. We can express this thing into kilometer also. 20.4 kilometer or about 13 miles. Next, complete this chart. One is given here, answered here. So distance, time, and average speed. First, distance and time are given, 60 meter and distance 60 meter, time 3 seconds. So average speed equal to distance divided by time taken. So 60 divided by 3, 20 meter per second. So here average speed for first case is 20 meter per second. Then second case number 2, here a time and average speed are given, but we have to find out distance. We know distance equal to speed into time. So 40 into 35, 40 meter per second into 35 seconds, 1400 meter. Remember, it is 1400 meter. Third one already it is solved, but here distance and average speed are given, but we have to find out the time. So how you can calculate a time? So time equal to distance divided by average speed. Fourth one, here distance and time are given. We have to find out the average speed. Average speed equal to total distance divided by time taken. So 80 kilometer divided by 2 hours. So answer will be 40 kilometer per hour. 40 kilometer per hour, because 80 divided by 2, 40. And fifth one, 150 into 10 to the power 6 kilometer. Distance is 150 10 to the power 6 kilometer. On the other hand, average speed also given, 3 into 10 to the power 8 meter per second. So time, same thing, time equal to distance divided by average speed. Last one, 1 kilometer, that means distance and average speed 330 meter per second are given, but we have to find out the time. Remember, here average speed in meter per second unit, so we have to convert the distance 1 kilometer into meter first. So 1 kilometer equals to 1000 meter. So time taken equal to distance 1000 divided by 330 meter per second. So we can calculate time 3.03 second. Next, distance time graph. Distance in meter and time in second. Here, when time is 0, then distance covered by the moving object is 0. That means when time is 0, distance is 0. When time is 40 seconds, then distance covered by the moving object 1000 meter. Then when time is 80 seconds, then distance traveled by the object is 2000 meter. Similarly, when time is 120 seconds, then distance 3000 meter. When time 160, then distance 4000 meter. When time 200 second, then distance 5000 meter. When time 240 second, then distance 6000 meter. We can plot this distance and time in a graph, which is known as distance time graph. We can plot this distance and time easily. Remember, when we plot a graph, then in horizontal axis we should put independent variable, and in vertical axis we should put dependent variable. What is independent variable? The physical quantity which changes or varies in an experiment is known as independent variable, and the things which we desire to measure is known as dependent variable. Slope or gradient of the distance time graph increase with speed. So if the gradient of the distance time graph is less, then it represents the object moves slowly. That means speed is lower. And if the gradient of the distance time graph is higher, then it represents the object moves fast. So speed is higher. Slope or gradient of the distance time graph is equal to the speed. So in the graph opposite, there is a distance time graph. Look at the graph. It is a straight line. So a straight line represents that the object moves with uniform speed or constant speed. So slope. So speed equal to gradient or slope of the distance time graph. Slope equal to change in distance divided by change in time. Remember, slope of a distance time graph equal to change in distance divided by change in time. Here, final distance is 150. Look at the graph, 150, and the final time is 10. So slope, final distance minus initial distance divided by final time divided minus initial time. So we can calculate easily 15 meter per second. So speed of the moving object is 15 meter per second. Now question number 1. Sketch on the same set of axes distance time graph for a car moving at steady speed. Steady speed. If the distance time graph is a straight line, a steeper straight line, then it represents that the car moves with constant speed or uniform speed or steady speed. A bus moving at steady speed greater than the car. So if the speed is greater, then the gradient must be greater. So the blue line in the distance time graph represent the distance time graph for bus. So it is more steeper than car. That's why the gradient of the distance time graph for the bus is higher. A lorry increasing speed from rest. So lorry increasing speed, that means gradient increases with time. The gradient of the distance time graph for lorry increases with time. Question number 2. Describe the motion of the 3 lorries X, Y, and Z shown in the graph below. Look at the graph here. There are 3 lorries X, Y, and Z. The distance time graph for X is a straight line. So the lorry moves with constant speed or steady speed. the distance time graph for y also a straight line but less steeper, or gradient is less than x. So y also moves with constant speed or steady speed, but speed is lower than x, lorry x. On the other hand, lorry z at the initial up to 600 second, 0 to 600 second, it moves with constant speed or steady speed. Then 600 to 1200 second, the lorry remains stationary or at rest, because distance does not change with time for the lorry jet 600 to 1200 second. Then again 1200 to 1800 second, the lorry moves with constant speed or steady speed. Now look at the solution. Here lorry x moving quickest because the gradient or slope of the distance time graph is more steep. Speed equal to 45,000 meter divided by 1800 second, so 25 meter per second. On the other hand, lorry y speed equal to 36,000 meter divided by 1800 second, so 20 meter per second. Lorry jet moving slowest because 0 to 600 second speed 10,000 divided by 600 seconds, so 16.7. 600 to 1200 second remains stationary. Then again 1200 to 1800 second, speed 16.7 meter per second. So average speed equal to total distance divided by total time. Total distance traveled by the lorry jet 20,000 meter and total time 1800 seconds. So average speed equal to 20,000 meter divided by 1800 seconds. So 11.1 meter per second. Now there is a fill in the gaps here. Choose appropriate words to fill in the gaps below. Look at the fill in the gaps first. Read first sentence. Speed is equal to dash divided by time. Speed is equal to distance divided by time. Distance divided by time can be measured in meter per second, because the unit of speed is meter per second. So answer, speed is equal to distance moved by time taken and can be measured in meter per second. Then second sentence, a speed of 20 meter per second is same as 72 kilometer per hour, which is approximately equal to the 40 mile per hour. Then third sentence, the slope of the distance against time graph can be used to calculate speed. The greater the gradient of the line, higher the speed. The line will be horizontal when the speed is 0. Now, velocity. The distance traveled by a moving body in unit time in a definite direction is called velocity of the body. So we can also say that the rate of change of displacement with time is called velocity. If the body traverses a distance s in a definite direction in time t, the velocity is v equal to s by t. Velocity is a vector quantity because it has both magnitude and direction. It has a specific direction. So velocity equal to rate of change of displacement with time. So rate of change of displacement is called velocity. Rate of change of displacement is called velocity. Velocity is related to displacement. Displacement is a vector quantity, that's why velocity also vector quantity. The unit of velocity is meter per second. A stone question, mathematical question, a stone dropped off the top of the cliff falls down by 20 meters in 2 seconds. Calculate the average velocity downwards and horizontally. Average speed downwards 20 meters divided by 2 seconds. So 10 meters per second. Therefore, velocity downwards 10 meters per second. But in horizontal average speed horizontally, there is no movement, no displacement occurs in horizontally. That's why displacement here 0 meter divided by 2 seconds, so 0 meter per second. Very important. Therefore, velocity horizontally 0 meter per second. So, therefore, velocity horizontally 0 meter per second. Now, acceleration. Acceleration equal to rate of change of velocity. Mathematical formula: acceleration equal to change in velocity divided by time taken. Acceleration is denoted by small letter a. A equal to final velocity minus initial velocity divided by time taken. So A equal to V minus U divided by T. Here A equal to acceleration, unit meter per second square. V for final velocity, unit meter per second. U initial velocity, unit meter per second. Time, T for time taken in second. So remember this formula: acceleration equal to change in velocity divided by time taken. Acceleration is a vector quantity because it has both magnitude and direction. Acceleration is related with velocity because velocity is a vector quantity, that's why acceleration also vector quantity. Why acceleration measured in meter per second square? Because acceleration equals to change in velocity divided by time taken. The unit of velocity is or velocity change is measured in meter per second. Time taken is measured in second. So therefore, acceleration equals to meter per second divided by second. That's why meter per second square. This is very important. The unit of acceleration is meter per second square. Meter per second square. Others notes: speed and velocity. Often, but not always, speed can be measured in the equation. Change in velocity, final velocity minus initial velocity, so V minus U, and deceleration. This is where the speed is decreasing with time. Circular motion at constant speed. Remember, when any object moves in a circular motion with constant speed, though its speed is remains same, but the direction of the speed changes gradually with time. That means direction of the speed varies with time. We know acceleration equal to rate of change of velocity. Velocity has two things. One is magnitude and another is direction. So in circular motion at constant speed, though speed remains same but direction changes. That's why there is an acceleration. Complete the table below for an airplane accelerating at 8 meters per second. So here initial velocity is 0 and time at time t, when time t0 velocity, that means initial velocity is 0. So we have to find out the velocity, final velocity after 2 seconds. We know final velocity v equal to u plus a into t. Here u for initial velocity, here initial velocity is 0 and acceleration is 8 meters per second square, so 8, and time 2. So final velocity after 2 seconds will be 16 meters per second. So after 2 seconds the final velocity will be 16 meters per second. Then what will be after 3 seconds? So after 3 seconds, again we can calculate by using this formula. Initial velocity 0, acceleration is 8, and after 3 seconds the velocity will be 24 meters per second. So answer will be 24 meters per second. Now tell me what will be the final velocity after 4 seconds. So 4 seconds, after 4 seconds it will be 0 plus 8 into 4, so 32 meters per second. 32 meters per second will be the final velocity after 4 seconds. So remember the equation which is used here, final velocity v equal to u, initial velocity, plus acceleration into time. Remember this formula. So sometimes we write u equals to at. Then next one, question number 2, calculate the acceleration of the car that changes in velocity from 5 meters per second to 25 meters per second in 4 seconds. Here 5 is the initial velocity, that means it is u, and 25 is the final velocity v, and t is the time here, time taken. We know acceleration equal to final velocity minus initial velocity divided by time taken. So here final velocity v equal to 25 and initial velocity equal to 5. So 25 meters per second minus 5 meters per second divided by 4 seconds. So 20 divided by 4, so 5 meters per second square. Remember the unit of acceleration is meter per second square. Remember this thing, very important. Now question number 3. Calculate the final velocity of a train that accelerates at 0.3 meters per second square for 60 seconds from an initial velocity of 5 meters per second. So we know the formula acceleration a equal to v minus u divided by t. After cross multiplication we can write v minus u equal to a into t. So here acceleration is given 0.3 meters per second square and time is 60 seconds. So change in velocity here 18 meter per second, but initial velocity u is given, so we have to find out the final velocity. So therefore the final velocity will be 5 meter per second plus 18 meter per second. We can do this math by using this simple formula, v equal to u plus a into t. So initial velocity 5 meter per second and acceleration is 0.3 meter per second square and time is 60 seconds. So we can write 5 meter per second plus 18 meter per second. So 5 plus 18, 23 meter per second will be the final velocity of the train after 60 seconds. So 23 is the final velocity. Now question number 4. Calculate the deceleration of the car that slows down from 18 meter per second to rest in 3 seconds. Remember, there is no different formula for deceleration. We know acceleration equal to final velocity minus initial velocity by time. So final velocity here 0. Why 0? Because here finally is rest. So it is the final velocity, it is the initial velocity, and time t is given here 3 seconds. So minus 18 divided by 3. Notice that this minus sign indicates that the car is decelerating. So acceleration equals to minus 6 meter per second square, but so deceleration will be 6 meter per second square. Note, deceleration is the negative of the acceleration. Remember, deceleration is the negative of the acceleration. Now complete the chart here. There is a mathematical problem. So we know the formula A equal to v minus u, final velocity minus initial velocity divided by time. So we can write also for final velocity time t equal to v minus u divided by a, and we can also write for final velocity v equal to u plus at. By using this formula we can solve this chart. Complete the chart. Here initial velocity u is 0 and time is 15, so acceleration is 3, so we can calculate final velocity easily by using this formula. So initial velocity is 0 and acceleration is 3 into time 15. So easily we can find out the final velocity will be 45 meter per second. 45 meter per second. Then same way you can calculate the time t equal to v minus u by a by using this formula. Here final velocity is 24 and initial 0, and a here a is 8, so we can easily find out the time taken is 3 seconds. Likewise we can calculate also third one, fourth one and fifth one. Very easy. Now fill in the gaps below. Choose the appropriate words to fill in the gaps. Velocity is speed measured in a particular direction. We know velocity is a vector quantity, so it has direction, particular direction. A person walking northward will have a dash velocity in the westward, zero velocity. Acceleration is equal to velocity change divided by time taken. Acceleration is measured in meter per second square. Deceleration occurs when a body is slowing down. It is possible for a body to be accelerating when its speed is not changing, provided its direction is, for example, a body moving in a circle. Now velocity time graph. Velocity time graph. The slope of the velocity time graph represents acceleration, because we know acceleration equals to change in velocity divided by time. If the velocity time graph gives a steeper line, steeper straight line, then it represents high acceleration. If the gradient or slope of the velocity time graph is low, then it represents its acceleration is low. That means low acceleration. If the velocity time graph gives a horizontal line with time axis, then it represents the moving object. The velocity of the moving object does not change with time. That means constant velocity or zero acceleration. Very important. Constant velocity or zero acceleration. If the gradient or slope downwards of a velocity time graph, then it represents deceleration or retardation. Then remember, very important thing, the area under a velocity time graph represents distance traveled. So look at the graph here. It is a velocity time graph. It is a straight line. That means the object moves with uniform acceleration or constant acceleration. So here the area under the velocity time graph is a triangle shape. So area equal to distance traveled. So we can find out the distance by calculating area under the velocity time graph. If the area under the velocity time graph is a triangle shape, then we can calculate the area by using this formula: half into base into height. If the area under the velocity time graph is a rectangle, then remember it is length into breadth. If the area under the velocity time graph is a trapezium, then the half into sum of the two parallel sides into distance between perpendicular perpendicular distance between two parallel sides. So we can write this formula in an easy manner: half a plus b into height. So area of the trapezium. Next one, sketch the velocity time graph of a car accelerating from rest. Remember, accelerating from rest, that means initial velocity is 0. Initial velocity is 0 here, and time, when time was 0. Raised to final velocity will be 15 meter per second in 3 seconds. Then at a constant speed for 1 more second. So here the final velocity after 3 seconds is 15. That's why we can draw velocity time graph in this way. Then after achieving 15 meter per second, then the car moves with constant velocity for 1 second. So for 1 second it moves constant velocity. So this is the velocity time graph for the given question. Then look at the question number 2. Calculate the acceleration and the distance traveled after 4 seconds from using the graph opposite. Look at the graph. Here initial velocity is 0 and time is 0 when time is 0. So first we have to find out the acceleration. From this graph it is observed that the velocity time graph is a straight line, steeper straight line. So it represents the moving object moves with uniform acceleration or constant acceleration. So acceleration equal to gradient or slope of the velocity time graph. So gradient y step divided by x step. Where y step final velocity 12 and initial was 0, so 12 minus 0, and final time 4 and initial was 0, so 4 minus 0, so 12 divided by 4. Acceleration equal to 3 meter per second square. 3 meter per second square. Now distance equal to area under the graph. Area here, area of the the velocity time graph is a triangle shape. So area of the triangle, half into base into height. Here base here 4 second and height 12 meter per second. So distance travel 24 meter per second. 24 meter. Now question number 3. Calculate the acceleration and distance traveled using the graph shown below. Look at the graph first. It is a velocity time graph. We have to find out the acceleration. So acceleration equals to gradient or slope of the velocity time graph. Here the final velocity becomes 12 and initial was 4. So 12 minus 4 and time 10. So acceleration equal to slope of the graph. So y step divided by x step. So 16 minus 4 divided by 10 second. So 12 divided by 10, 1.2 meter per second square. So unit of acceleration is meter per second square. So acceleration equal to 1.2 meter per second square. On the other hand, distance traveled equal to area under the area below the graph. So this is equal to the area below the graph. So there are two shapes here, area of the rectangle and area of the triangle. Look at the graph again. first area of the rectangle, then area of the triangle. So we can find out distance, area of the triangle 10 second into 4 meter per second, plus half area of the triangle, half base 10 second, and height 12 minus 4. So 40 plus 40, 80. Distance traveled 80 meter. Now question number 4. This is the homework for today. Try to solve the question number 4 and write the answer in the comment section. So calculate the distance travel over 15 seconds and the deceleration during final 5 seconds using this graph. This is the challenge for you. Try to solve this question number 4, and take a snap or photo using your mobile phone and send it in the comment section. I will check and I will give you a feedback. Okay, no more today. Khuda Hafiz.